Welcome back to Math Mini Lessons. My name is Sarah, and today we're going to do a two-day review or two-video review of the 8th grade state exam. I made these copies of the exam so multiple kids in the city now have it, and here's my advice to you. Take some time to actually go through the entire test. It is a full exam, so there are two sections. There's a day one and a day two. And day one is all multiple choice, and day two has a few multiple choice questions, and the rest are constructed response. If you live in New York, then you know that this year the state exam is going to be on computers for all 8th graders. So here's the way I would approach this review. Go through and try the exam yourself. You can do it on paper, or if you're doing it on the computer screen, you can, and then just use scrap paper to go through each problem. The day of the test, you're going to be given two pieces of paper. You're going to be given a regular scrap piece of paper, and then you'll be given a piece of graph paper. So I recommend you take your paper, fold it in half, fold it again, so you have 4 squares, and you work each problem in each of the squares. And just try and make sure you're going through it and just not doing it in your head, because as you can see, these problems are a little much to do in your head. Take your time, show your work, since this is completely untimed. And when you're done, you're going to go back to this video. And in this video, I'm going to go through the problems 4 at a time, meaning I'm going to give you the answers for 4 multiple choice, and then you'll check your answers, how you did on those 4. And if you had something wrong, then hit pause, go to those exact questions, and just watch how I review the problem itself. If you have all 4 of them right, you just move on to the next section. And that's what I did for all 32 problems. So this video will be broken up into about 8 sections for all 32 problems, so 4 at a time. All right, it is a longer video, so again, I would focus in on the problems where you felt challenged, the problems that were harder for you, the problems where if you made an error or you had a different answer, then I would absolutely review those, and for everything else, I would move forward. So that's it for today. I'm gonna stop here now, and we're gonna jump in to the first set of problems, numbers 1 through 4.
First 4 questions together, and the first one we're looking for an irrational number. This is a number sense problem, and the definition for irrational number is you should be able to represent it as a fraction, or you could think of it this way. It's irrational if you have a decimal form that is non-repeating, non-terminating, like it goes on and on forever. For example, the number like pi. So if I try to look at pi, you will get 3.14 and it goes on and on and on and on forever. That one would be irrational. Okay, so I'm going to put an IR there. Let's look at the ones we have here. If we evaluate them, so here's 1 and 5/10 squared. I get 2 and 25/100. It terminates. That means it is rational. If I try to do square root 4.1, you can see it keeps going on and on forever. 2.0248. It's not repeating, it's not ending. This is our irrational number. And the next set, 7, that's a whole number, it would be rational. And 15 squared would be 225, also a whole number, rational. Jot this down if you had this incorrect. Let's look at number 2. Which scatter plot best represents a linear association? So pretty much you're going to look for something that looks close to a straight line between x and y. It shows a relationship between them. So looking at our charts here, I can't draw a straight line through here. It would be curved, so we can just visually see that A is not linear, neither is C, neither is B, it's random, but D clearly is the closest to linear. It has the best representation out of all 4, even though it has an outlier right here. Let's move to number 3. And we have quadrilateral ABCD is graphed on the plane. Vertex A, let's highlight this. A is located at point -2,3, and we know it is dilated by a scale factor of 2. So this is not a rigid motion, meaning it's not staying the same size. It is changing, it is growing or shrinking. Here we have a scale factor of 2, which means it is growing by 2. So it's doubling with a center of dilation at the origin. So what we're going to do is think, we have the point for A, which is -2,3, and we want to know what A prime is. That is our goal. What is this here. Now, because it is dilated by a factor of 2, that means we are taking our x and our y and we're multiplying them both by 2. Okay? Which means we have negative 2 times 2 for our x and 3 times 2 for y, which is negative 4, 6. So the answer for that one would be B. All right, let's move. So that was our geometry question. So far we've had number sense, we've had stats and probability, geometry. Here we're going to have an EE question. What value for the constant h in the equation will result in an infinite number solution? So that's what we're looking for, infinite, meaning that both sides, both expressions will be equal to each other, have equal value. So we're going to think logically about this. We know that h is going to be distributed to both terms inside the parentheses. So what can we do so that if we know the left side is equal to 6x plus 18, what would we have to multiply the 3x by to get 6x? So just think logically. Well, I would just have to multiply by 2 because 2 times 3x would give me 6x. And would that also be true for the 9 to get 18? Yeah, 2 times 9 would be 18. So h has to equal 2. If you weren't sure how to do this, you could just guess and check and try the other ones out and just distribute. So for example, I'm just going to randomly pick one. So let's say I said my h was negative 3. I would just distribute and I would get negative 9x minus 27. And when I look, just looking at these terms, I can tell that they would not be equivalent to each other. So I know these are not. This would not create an infinite solution. Okay, so you could just try them out if you wanted to. Now, if you are still not sure, if you're used to it coming down to a single term, you could keep working this through. You don't have to, because we can see that this expression is equal to this expression. They're exactly equal to each other. But if you wanted to get it to a single term, we can make a 0 pair on the left, but it would also make a 0 pair on the right, and you get 18 is equal to 18. So again, infinite solutions. So hit pause and jot this down into your notes. Let's do the next 4 problems, 5 and 6. The answers are A and C. These are EE questions and function, and for 7 and 8, you would have C and B. It's another EE and another geometry question. So let's start with number 5. And we're just looking for the solution, which just means I have to solve for C. So the biggest hotspot here is usually a calculation error or creating 0 pairs. So I'm going to show both of those. I'll start by distributing. I get 2C minus 10. And the first thing I want to do is I want to create 0 pairs. And I'm doing that because I want all the variables on one side. I'd rather subtract 2C here to create a 0 pair so that I have a positive C here. So I have 3C. Because I know later on when I'm going to have to do some division, I'd rather divide by a positive number than divide by a negative. But there's no preference. You can do either one. Is equal to negative 10. Now, please make sure you're carrying that negative sign. Even I make this mistake one time. I put in just 10 and I had a totally different answer. So we'll keep on going. Now I want to create a 0 pair here because I want the C by itself. And so I have 3C is equal to negative 14. And now we're going to divide both sides by 3. And I get C. I'm going to give myself a little bit more space over here. C is equal to negative 14 over 3. Now, this is an improper fraction. You still don't see it anywhere. So you can just do your mental math to divide. 3 goes into 14 4 times. So it's negative 4. That's 12. And I'll have 2 left over, 2/3. So there you go. There's your answer for A. Just make sure you are keeping track of those negative terms. Very easy to forget to carry the negative sign, and then it'll give you a completely different answer. Let's move to the next one. Which equation represents a function that is not linear. So as soon as we see that for things that are linear, we know that those equations, when we graph them, are typically in this form: y equals mx plus b. And noticing that your y, it doesn't have any exponents, is usually to the first degree. Okay, that's going, when I graph that, that's going to make a line. So I'm looking for an equation that has that format. So let's look at the first one. I'm just going to simplify them out and to make it into a slope-intercept form, this basic form. So here I get y is equal to 4x plus 12. That works, is that same mx plus b form. And with the second one, even if I move the terms around, I have 3x plus 4 squared is just 16. That still works. It's still, I'm just moving the terms around, but it is still equivalent. Now with my next one, y is equal to 3x squared plus 4x. This square right here is not, that's why I'm not going to get something linear. I'm going to get a curved line. And with the last one, now this is tricky. This one here, this is meant to trick you. That's why it is there. But I can still write it in this form. Matter of fact, I can do, all I'm going to do is separate it out. So I have 4 over 3 plus x over 3. So it has fractions, but it looks ugly. But watch how I can rewrite that again. Y is equal to 1 1/3 plus 1/3 x. Or if you want to write it in mx plus b form, y is equal to 1/3 x plus 1 1/3, where my x is still in as a first degree. There's no exponent there. So that's it. D was my the part that I know most kids would get tricked on. So just make sure you have it. B is also another one that gets tricky because kids are looking for an exponent, but notice I can evaluate that 4 squared and make 16. So that was another place where they expected kids to make a mistake. So jot this down and let's go to the next two. The equation table below each represent a different relationship between x and y. Which statement about the function is true? Now, all of these are talking about rate of change. And all we're doing is comparing the rate of change. So let's look at the rate of change for both of these and figure out what they are. And here you're looking for the coefficient in front of the x. So my rate of change, I'm going to put ROC. For this one is 5/4 or 1.25. If you're unsure how I got that, so what I would do on a calculator. Now, how would I get my rate of change over here on B? I'm going to have to look for the change in y and the change in x. Okay, so let's look at my first set of numbers here. How is my y changing? My y is increasing by 1.5, 1 5/10, and my x is increasing by 5. And let's see if that's constant. Yes, this one is increasing by 1.5 to get from 3 to 4.5, and this is increasing by 5. So I'm going to represent that as change in y over change in x. And I get 1.5 over 5. We'll simplify that. And you're going to get our rate of change is equal to 0 3/10. So which one of these is larger? A, 1 2/5, 1 25/100, or function B, which is 3/10. Obviously, A is greater, and that's why C is the correct answer. A has a greater rate of change than B because, and this is our key, this expression right here. So why can't, we already can see why B and D are wrong because it's saying B is greater, so we know those are wrong. But let's look why A is incorrect. And it's because here the rate of change for B is not 3 3/10. So how could they have gotten 3 3/10? They made some type of error somewhere in not using change in y over change in x, or they didn't properly look at the changes here on the side. Okay. So we have this one done. Let's go down to 8. 2 points are plotted on a coordinate plane. Point A is plotted at -11, 8, and B is at -2, -4. What is the distance in the units from A to B. So we're going to have to make a visual of this. Because this is a computer-based test in New York, use your graph paper, please. For all of these problems, you should be using your scrap paper and graph paper. I'm going to use this as my paper just to make a very quick graph. And point A is at negative 11.8. So I'm just going to put it in this quadrant over here. It's not exact. Here's, and I'm just going to put the point negative 11.8. And point B is at negative 2, negative 4. So negative 2, negative 4. Let's say this is negative 2. Here's negative 4. Again, it doesn't have to be exact. Here's B. So this is going to make a slanted line. That means for the distance, I'm going to have to use the Pythagorean theorem. So watch what I'm going to do. I'm going to make an additional point right here at negative 11, negative 4. This way I have a right triangle, and I can solve this now. I can solve for our unknown side, and I'm going to call C. All right, so let's look at from our new point. This is A, this is B, and this is now our point C. Let's actually call that point C over here. So, and we're trying to figure out this side over here. So from C to B, I'm going from negative 11 to negative 2. So this side here is 9. And from A to C, I'm going from 8 down to negative 4. So if you need to count it down, you can think, well, from here to here is 8. And from here to here, it's a distance of 4. So this total distance is 12. All right, and we're going to find the other side. So now we're going to do a squared plus b squared equals c squared. And we're just going to use 2 of the legs. We know one leg is 12, one leg is 9. We need to figure out what the other leg is. And we're going to just square them. So I have 144 plus 81 is equal to c squared. That's 144 plus 81 is 225. Now, to find what our c is, we're going to have to do the square root of both of these numbers. And you should know your square numbers up to 15 squared, but if you don't, it's okay if you don't, you have a tool. On your calculator, you can do the square root of 225 and you'll get 15. And there you go. So a lot of skills here. You have to absolutely use your graph paper. And the tricky part for this part is making sure you can find a distance between 2 points when it goes into two different quadrants. So that was really important here to recognize just that from A to C, I had to do 8 plus 4 to get that total distance of 12. So hit pause, jot this down if you didn't get that correct answer. Okay, let's look at the next 4 together. 9 and 10, you have a number sense and a stats problem. So for 9, you get B, and for 10, you're also going to get B. For 11, you'll get A, it's a function problem, and for 12, you'll get D, it's also a function problem. So if you had any of those incorrect, we'll go through them. If not, skip to the next section. Okay, so the first one, which is the closest approximation to square root 45? And you get the numbers 6, 7, 8, 9, and 10. So what I'm going to do is I'm going to just draw a regular number line. 6, 7, 8, 9, those are our numbers. And I'm also going to put their equivalent. So the equivalent of 6 is the square root of 36. So the square root of 36 is the same as 6 squared, or 6. For 7, that would be the square root of 49. For 8, that would be the square root of 64. And for 9, that would be the square root of 81. So make sure that makes sense to you, how I'm getting those numbers. Now, so where would the square root of 45 be? It would end up being somewhere between these two numbers, between 6 and 7. But how do I know if it's closer to 6 or 7? So automatically, we're going to eliminate these two. Think about the halfway point. What would the halfway point be, which is 6 and 5/10? So what I'm going to do is I'm going to square 6 and 5/10. And that means the halfway point between these two numbers is the square root of 42.25. So that's super helpful because now I can see 45 is absolutely between these two numbers, therefore is absolutely closer to 7 than it is to 6. Okay, so notice how I'm using my square numbers to help me figure this out, where the number is. By finding, if you can't tell if it's between two whole numbers, try and find a number in the middle to see what that will be, and you can use your calculator for that. Let's look at the next one, number 10, and it has a scatter plot is shown, can be used to find the approximate rate. So again, it's just an approximation of water flowing through a garden hose. The best fit for the scatter plot can be described as y equals 4/5 x. If the rate in gallons per minute continues, approximately how many gallons of water will flow in 45 minutes. Okay, so here's our rate. We have y equals 4/5 x. We know that the rate is 4/5 gallons per minute. That's our rate. Gallons per minute. Again, because we're thinking about the change in y over the change in x, and our y is gallons and our x is time. So we're going to do that part. So I'm going to make a ratio table because what we want to figure out, again, this is gallons and this is minutes. We want to solve for when we have 45 minutes. And here's our unknown. So I'm going to just some of you might automatically see, well, I can see a pattern here. I'll just multiply by 9 and just multiply by 9 and get 36. If that works for you, definitely do it. Now, if you're not sure and you want to just use your complete algebra, you can use cross products. And by cross products, we're going to multiply across. So I get 5x and multiply across. And you get 4 times 45. Which is, I think, 180. Yep. 5x is equal to 180, and divide both sides by 5. And you'll get 36. So both work. And there you go. That's how you can find the rate on the table and use that to find the approximate number of gallons for any additional time period. So take a moment, jot this down if you need to, and let's move on to number 11. At a factory, the cost of making different numbers of toothbrushes is shown in the table below. A linear function models the cost based on the number of toothbrushes made. So we're thinking about cost, the number of toothbrushes made. Which statement about the rate of change of this function is true? So again, we're looking at rate of change for each one. So we're looking at the cost per toothbrush. So here is our y to our toothbrushes. So we're going to look at the change in y over the change in x. So how I can use any of these, because this is linear, it means this will be true for all of them. For the first one, let's represent that I have 450 for 3 toothbrushes. So how much is that for one toothbrush? $1.50, I believe. Yep, $1.50. Let's see if that's true for all of these. Let's try the second one. $9 for 6 toothbrushes. Oops. Here we go. $1.50 each toothbrush. And so this is probably going to be true for all of them. It says it's linear, so it should be true for all of them. Here's for 9 toothbrushes. $13.50. Hold on. There we go. So $1.50 and $18 for 12 toothbrushes, $1.50. So that is the rate for every single toothbrush. The rate of change is $1.50 for one toothbrush. All right, so let's see why A actually works, because it has that complete rate of change. That's why A works for this one, and why it doesn't work for B, because this doesn't make sense. The cost increases by $4.50 for every toothbrush. No, that's not true. We know it's going up by $1.50 for each toothbrush. Okay, $1.50 per toothbrush. So the other ones do not work. You had to find the rate of change. The other hotspot for this was figuring out which is the y and which is the x. So I always use the cost based on the toothbrush. So that means the cost is my dependent variable and the number of toothbrushes is independent. All right, let's go to number 12. The rule for a function of x is multiply by 2, then subtract 6. So, okay, so I have x times 2 and then minus 6. I'm going to write that another way, 2x minus 6. I like the way that looks. So the data said the input values of the function is -1, 1, 3, 5. What is the value? Which of these is a value for y? Okay. So here's my rule. I know what my rule is. So when I have -1, and all you would do is you would just put these in. So 2 times -1 minus 6. So -2 minus 6 is -8. Not there. It's not an option. Now we'll do the same thing for 1. 2 times 1 minus 6. So 2 minus 6, I get -4. Not an option. I'll put in 3. 2 times 3 minus 6. So that would get 6 minus 6, which gives me 0. Again, none of these are options for y. And lastly, we'll do 5. 2 times 5 minus 6. So 10 minus 6 is 4. That's why this is the answer. Okay? So all I did was I took that rule and I input it. I used my input to figure out which one would make y. So there you go. This is the only value that's here on my list. What's tricky about this? Well, I could see some people getting tripped up by B because you're putting in a -1 in this first one. So I'm curious to see if that was the most popular answer when kids, the most popular incorrect answer when kids took this question. So hit pause, jot this down, and we'll go into the next 4 problems in the next section. All right, let's look at numbers 13 and 14. For 13, you have C, and for 14, C. This is an EE and a stats problem. And for 15, 16, you have B and B, an EE and a geometry problem. Keep saying geometry. All right, let's start with the first one, number 13. And we're looking for what is the number of solutions to the equation below. So again, what you're looking for are 3 different conditions. If you get x is equal to some number, then we have one solution. If you get one expression equal to the other expression, like both sides are exactly the same, we have infinite. And if we get something that's completely an untrue statement, then we say there are no solutions. So that's what we're looking for here. Okay, and there's no such thing as 2 possible solutions, so you know you can get rid of B. It's either 1, none, or infinite. Okay, so let's walk through this one. Let's do it together. 2 times x minus 3 is equal to 2x plus 5. We're going to distribute and get 2x minus 6 is equal to 2x plus 5. So just looking here, we know it can't be infinite because we have the same terms, 2x and 2x, but these terms are different. Okay, so we know that definitely they're not infinite solutions. There's either going to be 1 or none. So what we're going to do is we want to get all the x's on one side. So I'm going to do that. Here I get a 0 pair, but here's this is a red flag. I get 2 0 pairs. So now I get -6 is equal to 5, which is absolutely not true. Therefore, there are no solutions. So there we go. And that was my red flag because here these canceled out and it gave me a statement that just was not true. Let's look at number 14. A shoe size and the heights for 20 classmates were plotted as ordered pairs on the scatter plot. A line of best fit was drawn to model the data. Which scatter plot shows the most accurate line of best fit? So pretty much with a line of best fit, it most closely resembles the line, and where it's pretty much the way I used to learn was hey, it represents most like the average of all the lines, so it's kind of like close to an even split unless you have a heavy outlier. So with the first one, the problem is that here's my line, but look at all of these points here that are underneath that line. So many of these are under here, so I can't call this a line of best fit. For B, same thing happens. Look at all of these points that are just under. That means my line should be a little lower somewhere on it. Same thing with D. It should be a little bit lower because I just have so many points. But when I look at C, notice how it's pretty evenly distributed, where I have some lines on top and some lines on the bottom. So this is kind of like right in the middle. It's like the best fit for all of them. So that's why that makes the most sense. Let's go down. So 15, we have exponent rules, and just looking at all our choices, we want to find out which one has the same value as 1 over 16. And looking at what we have here, I can see two rules that are going to make sense. We have a negative exponent rule, because I have negatives all right here. And I also have another rule happening here. I have a power of powers rule. So we're going to evaluate all of these just so you can see what we're going to do. So with A, all this really means is I'm going to multiply these two exponents here on the top. So let's do that. So I get 2 to the 4th, which now evaluates to, here we go, 16. So that doesn't match. With the next one, I get 2 to the negative 4th, which I can also rewrite as 1 over 2 to the 4th, which is 1 over 16. Now, kind of a hack, you could type this into your calculator. The challenge is that it's not going to give it to you as a fraction. So that's the problem part. You actually have to evaluate it out. But I can use my negative exponent rule to write 1 over 2 to the 4th. And when you do that, oh, you're still getting that, huh? Interesting. So I would just do 2 to the 4th to get the 16, and I would just write it as 1 over 16. With the next one, I'm getting 2 to the negative 16. So that's not going to work because I'm going to get 1 over 2 to the 16th. And 2 to the 16th is a really big number. So nope, that doesn't work. And the same thing with this one, I get 2 to the 16th power, which is also not going to give me a fraction. It's going to give me that big number. So you got to know when to see our rules and to recognize them. And that's new for 8th grade. To be fair, that's something that I used to see a lot more in Algebra 1. I didn't always see it in 8th grade, but it's back in 8th grade. Okay, let's look at the next one. It's a volume problem. I like volume problems. A cylinder has a radius of 4 8/10 feet and a height of 8.1 feet. What is the volume closest to the nearest tenth? Okay, so you do have to look back at if you don't remember what the formula is for volume, you can go back to the reference guide. So volume of a cylinder is the area of the base, which is a circle. And so this is for any volume, the area of your base times the height. So because I know our base is a circle, and the area of a circle is pi r squared, I'm going to multiply that by the height. Okay, so we have our radius is 4 8/10, so 4 8/10 squared times our height, which is 8.1 times pi. So I'm going to evaluate the other numbers first. You are going to need to use your calculator for this. And notice how I want to capture everything. So I get 23 and 4 times 8.1. And I'm simplifying, get 186 and 624 pi. Now this one is not asking me to write this in terms of pi, so I have to keep going. So I'm going to put 186 624 pi into my calculator, and I get 586.296. I want to go to the nearest tenth. So because the number behind it is a 9, I'm going to round that up to 586.3. Okay, so jot this down. Again, use your reference table if you're not sure what the volume formula is, but if you can't, if you're familiar, it's always the area of the base times the height. And I always remember area of a circle because I know for circumference, cherry, pie, delicious, and for area, apple, pies are too. That's how I always remember it. So hit pause and jot this down, and we'll go to the next set of problems. Let's look at the next four. Here's 17 and 18, both function problems. The answers to both are B and B. And 19 and 20, you have A and D, a geometry and an EE problem. All right, so if you have any errors, let's go into them here. If not, go on to the next section. So for number 17, we're looking to see which ordered pair. All of these ordered pairs make a function. The relation is a function. Which point when added to the first set would not make a function? So that's what we're looking for in this set. So what I'm going to do is I'm going to make our table, and I want to just ensure that there is only, for every x, only one value of y. So we have -2, 8, 4, 6, and 10, 4. So far all a function. So when I put the first one in, 0 and 6, this is still okay. It's okay for y to have two different input values, still a function. But when I put in b, so there's a 4, notice there's already a 4 there, but now my answer is 2. This is the problem. I can't have two different values, outputs for 4, and that's why b is not a function. So when you see that, when an x value has two different values, it is not a function. But it is okay to have two different x values give you the same y output. That would be okay. All right, so let's go to the next one. The function of x is shown on a coordinate plane. Over which intervals is the function increasing? I like these. So all I'm going to do is I'm going to break this up into where I see my function changing. And you can see the 3 different points where everything changes. So in the first one, I notice it is increasing. In the second set, decreasing. Third set, increasing. And here's my fourth. When I broke it up, it is decreasing. So I just need to know when it's happening. So in the first one, I notice is increasing from -4 to -2. So x from -4 to -2. So I could automatically eliminate C and D. And then the next part is when I get from 0. So when x is 0, so let's put that in, up to when x is 2. So there you have it. Those are our values. So that's all I'm doing, is I'm just noting when it's increasing, and it's between those two. The reason why, of course, A doesn't work is because it's going from -1, and that's not true. When I go to -1, it's still decreasing. Let's go to the next step. Number 19, transformations. I really like these. And we need to figure out which sequence of transformations is going to map the triangle to the other side. So just looking at these, what the easiest way I would think to do this is just go through them one by one and seeing if it's true. And just trying it out. So with the first one, I have a reflection over the y-axis. So it would be reflected over here and then translated up to. So I will tell you the hot spot that happens here. We sometimes read from left to right. That's normally how. And I see a lot of kids trying this first and moving this triangle over the y-axis. But that is our prime. That is not our original triangle. Our original triangle is right over here. So we're going to change those values. So watch as I do them. So first, I'm going to reflect the A point. So it's over 2, it's 2 away. So 1, 2. So 1, 2. And then the same thing I'm going to do with B. 1, 2, 3, 4. 1, 2, 3, 4. Now notice I'm moving it spaces, but my values are scaling by 2. So it's really 8 away from the axis. And my C is going from 10 to negative 10. Okay, so that's the first thing that happens. So that's my triangle. And then it says to translate up 2 units. So this is the second part that can get kind of tricky. Oops, wait, I made a little challenge here because my C is right over here. So this is the second part that gets super tricky because a lot of us might go, well, 1, 2, and it's up here. But again, notice, look at our scale. To go up 2 means to go from here to here. From negative 4 to negative 2. B is going from negative 8 to negative 6, so that's the exact point. And C is going from negative 5 to negative 3, which does make our triangle. So there were 2 hot spots there, so please make sure you pay attention to the scale because this scale is not by ones. And also ensure that you're starting from your original to your primes. And you can tell that by looking at the symbol. So make sure the 2 hot spots in there. And so yes, it reflects over the y-axis and then is translated. And just that first part, the y-axis, I knew I can eliminate C and D. Okay. And like I said before, the hot spot was if you started on the left, if you moved this one over and then you probably moved it and went down to, and that they were counting on kids making that mistake. So just make sure you're reading the question correct. So what we're going to look for is an equation that passes through these 2 points where our x-intercept is 9, 0 and our y-intercept is 0, negative 5. Now this one's easy to figure out. Our y-intercept is usually to figure out our 0b. It's when x is 0, we get that second number b. And if we're looking at equations in y equals mx plus b form, we can see that y coordinate right over here is supposed to be negative 5. And that's true for all of these. So all of these have negative 5. So that's not helpful at all. So now we have to go to the next part, which is pretty much to figure out if I were to put in those values, the 9 and the 0, which one would be true. So that's what we're going to try. We're going to actually substitute in our 9 and our 0. So I'm going to just try it out with the first one so you can see. So here I have y equals negative 9/5 times x minus 5. So we're going to try putting in these points, 9 and 0. So here, I'm going to put 9 over 1. And for y, I'm going to put 0. Okay, so we're going to try this in. Would this be true? So if I were to evaluate this out, I would get negative 81 over 5 minus 5 is equal to 0. Not true. Just looking at it, I know it's not true because 81 divided by 5, I think that's what, 16.2 minus. It doesn't work. So this one absolutely not true. So I know A is not true. So I'll try going to the next one. Again, when y is equal to 0. So here I have 9/5 times, and I'm going to keep the same thing, the 9 over 1 minus 5. So again, when I evaluate this out, I get 81 over 5 minus 5 equals 0. Also not true, because I know again I'm getting 16 and 1/5 minus 5 is not equal to 0. So this is not true, so I know B is not true. All I'm doing is substituting my values, my coordinates for 9, 0. That's all I'm doing. So I'm going to do the same thing with C. 0 is equal to negative 5 ninths times 9 over 1 minus 5. Now this one gets interesting. So I get negative 45 over 9 minus 5. So 45 divided by 9 is negative 5. So negative 5 minus negative 5 looks close, but still not 0 because, of course, minus 5 minus 5 is going to give us negative 10. So very close. And what they're counting on here, this was our hot spot, they're counting on kids seeing 5 minus 5 and just getting 0. So that's an easy calculation error. And We'll do the same thing on the side with the other one. 0 is equal to 5/9 times 9/1 minus 5. So 0 is equal to 45/9 minus 5. 45 divided by 9 is 5. 5 minus 5 is equal to 0. So that is our answer D. So this one again was a little bit more complicated because if you're really struggling through it, you had to substitute through to figure out which one made the most sense. So hit pause, jot this down to make any corrections, and we'll go on to the next section. Let's look at the next 4, 21, 22, 23, and 24. So here are the answers for 21 and 22. I have A and C. Now I do want to note that 22 is from 7th grade, so it's possible it's been a long time you had a different answer, and we'll go through it. And here's 23 and 24, another geometry and SP problem, C and A. So again, if you have any incorrect, we'll go through it in this section. If not, move on to the next section. Starting with the first one. So I want to know what is the solution to the equation. So all I'm doing is solving for x. So 2/3 x plus 5 is equal to 1. I'm going to create a 0 pair. So I can start isolating, and I will just have the coefficient 2/3 x on this side, and I'll have -4 on the other expression. And now this is where I have to divide by 2/3. So I'm left with x is equal to -4. And this is a complex fraction. I'm going to rewrite it this way. Okay, and now I'm actually going to multiply by the reciprocal. So x is equal to -4 times 3/2, which is the same as -12/2, which is the same as -6. So there you go. That's how you get the first one. So tricky parts are just making sure that you are using your 0 pairs, first dealing with your constant, and then you're dividing by your coefficient. And even though it looks like a complex fraction, we can solve that by just making it look more friendly. Here's our 7th grade question. Trent draws a triangle and one interior angle is 34 degrees. Which angle measured could be the other two angles? So what do we already know? We know that the sum of the angles in a triangle are equal to 180. All right, so all three, I'm going to call them x, y, z. Now we know one of them is 34. So what I can do is we can subtract out to figure out what would be left over here. And we know that these two angles, x plus y, have to be equal to 146. So now all you're going to do is look to see which of those two angle pairs make 46. And 66 plus 80, here you go, oops, is 146. That's all you had to do, was just add them up together to see that they make 146. So that is our correct angle. That's it. Let's go to number 23. Nathan observes the growth of a sunflower plant. For a science project, he collects data on the relationship between the height of each sunflower plant during a 30-day period and the amount of fertilizer in grams of each plant. So height and grams of fertilizer. The equation for the line of best fit is y equals 0.35x plus 2, where y is the height of the plant and x is the number of grams. So that's important. So I'm going to put that in. Y equals 35x plus 2. And this is our height. And our x is the grams of the fertilizer. Okay, so we're going to try and evaluate this in terms of figuring out, so what does this mean? That's what we're trying to figure out. What is the slope? What does the 0.35 mean? So think about this for a minute. We know that 2 is just going to be our initial height. It's just where we start in the graph. And we know that for every 0.35, we get grams of fertilizer. So this is pretty much telling me every single time I add a gram, every time I put per gram of fertilizer, my plant is growing 0.35. That's all it means. So 0.35 centimeters per gram. So notice how, again, I'm looking at my y to my x. So if my y is the height in centimeters, so that's what it means. It means 0.35 centimeters per gram of fertilizer. And that's what this is telling me, the average growth of the plant per gram of fertilizer, right? I know it can't be height because we know our height is y. It can't be the amount of fertilizer used because that would be our x. And it can't be the amount of fertilizer per centimeter because it has to be y over x. Let's look at 24. Line CD is graphed on the coordinate plane. The line segment is reflected over, so CD is reflected over the x-axis and then rotated at a 90-degree clockwise about the origin. So there's a lot of visual stuff here. If you have paper, this works really, really well. Okay, so I'm going to try just drawing this so you can kind of see what I mean. I'm going to just pretend for a minute that I put line segment CD on a coordinate plane and it's going to be reflected over this line and then moved over. So just imagine I'm going to have like a line somewhere and I'm going to reflect it over here. I'm going to move it and then I'm going to turn it clockwise. I'm going to rotate it over. So let's see which of these makes sense. So all this is asking us is which statement will be true. I have to read them one by one. First one is true. It's still congruent. It doesn't matter how much I'm moving around because these are all rigid motions. Meaning me flipping it and turning the paper does not change the size. So that is true. With the second one, I don't have enough information to know any of this. Because I don't know what the line is. And even if I flip it and move it, I can't tell if it would be perpendicular. So, nope. With the second one is the line segment will be twice the size. This would only be true if I had a dilation of some sort. If I was shrinking it, then maybe that could be true. But that's not happening here. I have a reflection and a rotation. So not true. And the last one is the size is 1/2. Again, this would be a scale factor where I have a shrink here and the other one would be a grow. So that's all here. I just want to see if you can recognize it. All right, so let's hit pause, jot this down if you had to make any corrections, and we'll go on to the next section. Here are next 4, 25 and 26. You get C and D, a geometry and a function problem. 27 is A, 28 is A, an SP, and an EE problem. All right, so if you had any errors, we'll go through this section. If not, go move forward to the next segment. All right, with the first one, geometry, what is the value of X? And we know that this is cut by a transversal, so that's going to be important. We have two parallel lines cut by a transversal. That means that I know that this and this angle are going to be congruent to each other. So that means I can say that this expression, 13x plus 6, is going to be congruent to 11x plus 30. And now I can just solve for x by isolating the variable. I'm going to create a zero pair here just because I like my x values to be positive. So I have 2x plus 6 is equal to 30. Subtract 6 on both. So I have a zero pair here. 2x is equal to 24. And now I can divide by 2. X is equal to 12. So very simple, just algebra skills, even though it is a geometry problem. But the key is you had to know that these two angles were going to be congruent to each other. So look for parallel lines cut by a transversal so we can have this down. All right, let's go to the next one. We have two functions and we want to be able to compare the functions together. We're going to compare the rate of change. So let's look at the first one. In function A, you have the taxi driver has a base amount of $3 and the amount is $2 per mile. All right, so if you were going to write that down for A, you get y is equal to 2x plus 3. And in B, you have the equation 3x plus 2. They're giving it to us, which is awesome because now we can compare them. Y is equal to 3x plus 2. And we're comparing the rates of changes as well as the initial values. So what do we know about the rate of changes? I can see that the rate of change is higher for B because it's a 3. But I can see the initial value is higher for A. So that's why I love it when they're both in the same form. So looking at that, the only one that is true is D, because it says right over here, function B has a greater rate of change, which is true. And the initial value for B is less than the initial value for A, which is also true. So those two statements. Down. Again, super helpful to just have equations in the same form so we can make that comparison. But the key here was to recognize where the rate of change is, which is of course our coefficient to x. Let's go to 27. We have a scatter plot. Which equation best models the data? So again, we're thinking about best models. So you're kind of looking for a line of best fit. And it's not perfect because they are kind of spread out, but just taking a look at what you see in the points, I can see that they're kind of decreasing. And what does that tell me? It tells me I'm going to have a negative slope. So that's the first thing I can see, that whatever the slope is negative. And looking at my y-intercept, it's going to be somewhere around here. So my b value is going to be somewhere there. So just looking, I know I can definitely eliminate b, because here it says my b value will be -6, which would be all the way down. It's not even on this graph. And I can eliminate d because again, my b value is negative. Both of those are not true. So now we're stuck with A and C, and they both have negative slopes. So this is where, again, you can look to see like which b value makes sense. This one absolutely makes sense, that is closer to 6. It's definitely not all the way down here. Not true. So I can definitely eliminate that. And does my slope make sense? So this is saying, let's see how we can graph this out. I'm going to graph it for you. It's saying if I started at 6 and my slope was to go down 3 over 4, 1, 2, 3 over 1, 2, 3, 4. Down 3, 1, 2, 3 over 4, 1, 2, 3, 4. So this would be my line. And that's pretty good. That models very closely to what I have here as a line of best fit. So that's another way you can look to see, does it make sense? And jot this one down. All right, let's look at 28. What is the solution of the equation? So we're going to have to do a lot of EE skills. So I'm just going to give ourselves some room. And again, take your time with these because it's very easy to make an error. And we're going to start by distributing. 1/2 times 6 would just be 3x. And 1/2 times -2 would be -1. All right, now I can combine like terms. Perfect. So I can't combine any terms in either expression. And now I'm going to put my variables on the same side. Again, I prefer having a positive coefficient for x. So 7x minus 6 is equal to -1. And I'm going to add 6 to both sides. And again, if you're going to make an error, common error would be when we're adding positive and negative integers. -1 plus 6 is 5. And now we're just going to divide by 7. So x is equal to 5/7. And there you have it. All right, so hit pause, jot this down if need be. And again, notice how I take my time. And you have your calculator, so if you're really stuck, you could always just double check. Things like -1 plus 6 is 5 if you have a calculator. All right, hit pause, jot this down, and we'll go to the next section. Okay, let's look at the last 4 problems in session 1. We have 29, was it a geometry problem? The answer is A. Please check to make sure I did have a typo on one set of PDFs. So A should have been over the x-axis and B over the y. So just check that your copy has that. 30 is D, EE is an EE problem. 2031 is an EE problem. The answer is C. And the very last one for this section is a function problem is D. So check to see if you have those four answers. If you're correct, then congratulations, stop here and you can count up how many answers you had right for the number of points for day 1 and move on to the next video. If you had an error in these four, we're going to go over them right now. All right, so for the first one, we're looking at the types of transformations of ABC, the triangle A prime, B prime, C prime. So here's our original triangle. It's this little one right over here. And our new triangle is the one on the bottom. And just by looking at it, you can see that there's a reflection. And I've reflected it right over this x-axis. Matter of fact, you'll probably see like a reflection over the x-axis. You'll see that. And then you can see that it's stretched. It went from small to big. So this is also a dilation with a number that is greater than 1. So that number is greater than 1 because it is growing. If it's smaller than 1, when we multiply by a fraction, it would shrink down. So looking to see which one makes sense, all four of these have dilation as choices. So we know these are all dilation, so you read more. So A and B have a scale factor of 2, so that means that we're multiplying by 2, we're getting bigger. But C and D have a scale factor of a half. That would make it get smaller. So we can eliminate C and D as they would shrink or reduce our triangle, whereas we know our triangle is going from little to big. And the second one is a reflection over, it's either the X or Y axis, and obviously we know that this is the X axis, and that is why we choose A. If it was over the y-axis, then we would have it somewhere, we would have it here somewhere. Okay, so let's stop there, make any corrections, go and go to the next one. The volume, a cube has a volume of 64 cubic inches. What is the length of each side of the cube? Now, you can see this different ways. We can look at it as volume equals length with height if we were thinking of any rectangular prism, but this is a cube, so volume of a cube, we can, since all sides are the same, length with height would be the same number, I can use side cubed. So let's just evaluate from here. We have 64 is equal to side to the third power. So what we're going to do is find the cube root of 64 so that we can get one side. Okay, so again, you can use your calculator for this if you'd like, and the cube root is 4. Or you could have just tested each of these out and tried it out. And if you tried with the smallest number, 4 times 4 times 4, you would have gotten 16 times 4, which is equal to 64. Let's look at the bottom one. We want to know what value for t satisfies the equation. In other words, it would make it true. So we have 3t plus 4 minus 2 times 2t plus 3 equals negative 4. Hotspots, make sure you're distributing and be very careful with those positives and negatives. So here we have 3t plus 12 minus 4t minus 6 is equal to negative 4. Now we're going to combine some like terms. I'm going to put my like terms together. Positive 3 minus 4t, that means I'm going to have a negative 1t. And 12 minus 6 is just 6. Is equal to negative 4. Right, we're going to isolate. We want the t by itself, so let's make a 0 pair here. So now I'm left with negative t is equal to, on this side, sorry, that looks a little funky there with that extra sign. It's just a negative 4 on that side. Negative 4 minus 6 is just negative 10. Now, I have to deal with that negative t, and so I'm going to divide by negative 1. Divide by both sides by negative 1, because I want to find the value of t. So here we go. Now I have t is equal to 10. And I could always go back and substitute and actually put these numbers in, just as a check. So 3 times 10 plus 4 minus 2 times 10 plus 3. I want to make a space here. And that should equal negative 4. So I get Let's do what's in the parentheses first. 3 times 14 minus, in the parentheses I have 20 plus 3. 2 times 23 is equal to negative 4. And it just makes sense. Why throw away these points? Just check your work. So 42 minus 46 equals negative 4, and that is a true statement. Negative 4 is equal to negative 4. And if you're ever unsure again with adding or subtracting with positive negative numbers, just put them into your calculator. Okay, let's move on to the next one. And here we go. We have a graph of a function, and we want to know which correctly describes the function of a given interval. So let's look at the intervals we have here. I'm going to just separate this where I see the functions changing. And think about some trends. So on this part, it is increasing. It's also non-linear because it's curved. In this middle section, I'm going to call this B, this middle section, it is constant. So there's no change happening in our slope. In this third section, C, it's also increasing and it's also non-linear. And in D, it is decreasing, so negative slope, and is also non-linear. Now again, if you want to know the actual points inside, remember you can just think of the points from here to here and say this X is every point from, for example, -7 to -4. So if you wanted to be able to read out the points, you can just literally identify the X value where our function changes. And looking here, so for the first one, it says the function is decreasing and nonlinear between x minus 7 and x minus 4. So that was that first section we were just talking about right over here. And it is nonlinear. That part is true, but it is not decreasing. So that is false. And that's what you do. You go through each of these to figure out, are both statements true? And the only one that has both of them true is D, where between x is 4 and x and 11, which is over here in this section over here, D. It is decreasing because it's going down, and it is nonlinear because it's curved. So the correct answer is D. And that's it for this last one. Let me just make sure. Yeah, that's the end of session 1. Again, there are 32 questions. Each question is worth 1 point. So you can add up to see how many you would have gotten correct on your first try. And if you made some errors, you have time to go back and review and figure out how to fix them before the state test next week. That's it for today. In the next video, we'll go through session 2. I'll see you next time, Math Marbles. Be well.